friends, welcome to our YouTube channel. In today's class we are going to learn about the self-induction, and coefficient of the self-inductance. So first start with the concept of the self-induction. Self-induction, त्याच्या आधी आपल्याला हे माहित पाहिजे की induction process means what? Induction means what? Whenever a current is flowing through the coil, there is development of flux, electromagnetic flux and vice versa. म्हणजेच आपण जे आतापर्यंत बघत आलेलो आहे की एक सर्क्युलर कॉईल आहे, त्याच्यामध्ये जर मॅग्नेटिक फील्डमध्ये ते जर सबस्टिट्यूट केली असेल कॉईल, ऑटोमॅटिकली द करंट और EMF इज डेव्हलप्ड, दॅट मीन्स करंट विल स्टार्ट थ्रू द कॉईल. सो अचानक त्याच्यामध्ये इंडक्शन मीन्स सेल्फ डेव्हलपमेंट जर होत असेल तर त्याला म्हणतात इंडक्शन. सो देर आर टू टाइप्स ऑफ द induction. So in this lecture we are going to learn about the first type, that is self-induction. So self-induction, how we can explain it? See here, the property of a coil which enables to produce an opposing induced EMF in it when the current in the coil changes is called as self-inductance. म्हणजे काय? Whenever we are placing a coil inside the magnetic field, then current will start to flow through it, and that current opposes the magnetic flux. So opposite magnetic flux or opposite EMF is developed in the coil which opposes the magnetic flux. Okay, this process is called as a self-inductance, and here the EMF is induced in the same coil, hence this is called as self-inductance. ज्या कॉइल थ्रू फ्लक्स पास होणार आहे त्याच कॉइल मध्ये EMF डेव्हलप होतो. ओके, सो आय हॅव एक्सप्लेन विथ द डायग्राम ऑल्सो. सी हियर द डायग्राम. हियर अ बॅटरी इज कनेक्टेड विथ अ कॉइल and that is connected with a key, and that lines which are passing through the coil, it is called as a flux, magnetic flux represent केलेला आहे. So when we pass the key at that time, सध्या तरी ते कॉइल आणि मॅग्नेट वगैरे काही यूज केलेलं नाहीये, कॉइल ॲज इट इज आहे. इमेजिन whenever we are pressing the key, the circuit will start to conduct the current through the battery. So the current will start to flow through the battery and it will continue flow through the spirals of the spring. त्या कॉइलचे जे जेवढे टर्न्स आहेत त्याच्या थ्रू हे करंट फ्लो होणार आहे. Hence there is development of the EMF, that magnetic flux which is passing across this coil, and there is EMF induced in the coil. Okay, now we'll learn about the coefficient of self-inductance. Okay, self-inductance चा coefficient हे learn करायचं असेल तर we have to know that the flux and the current flowing through that coil, it is related. As the current is flowing through the coil, the flux will change, or whenever the flux is changing through the coil, the current is changing. That means the magnetic flux linked with the coil, it is directly proportional to the current. Okay, so that magnetic flux and current relation we can write as in the form of equation phi flux proportional to I current. Now we can write proportionality sign as a L, constant L. So phi is equals to L into I, where L, it is the coefficient of self-inductance. It is constant of proportionality here and it represents the coefficient of self-inductance. Okay, now how to define this coefficient of self-inductance? आहे या इक्वेशन मध्ये. Which equation? Phi is equals to L into I. Let the current flowing through the coil is of 1 ampere. Okay, current 1 ampere. If current is of 1 ampere, what is the concept? This equation changes. Phi is equals to L into 1. म्हणजेच phi is equals to L. Means magnetic flux equal to the self-inductance. That is coefficient of self-inductance. That means coefficient is equal to the magnetic flux linked with the coil when unit current flows through it. So this is the first type of the definition for the coefficient of self-inductance. When current is 1 ampere, the magnetic flux flowing through the coil is nothing but the coefficient of self-inductance. Okay. Now there is another method to define it. Let's see this. Now we know that EMF is equals to E is equals to minus d phi by dt. Minus d phi by dt by the Lenz's law. Okay. Now what is phi? We know that it is L into I. So substitute here. We are getting here minus d by dt L into I. Now L, it is a constant of proportionality, so it remains constant. So it is outside the differentiation sign. So what is the next step? It is minus L di by dt. Okay, rate of change of current with respect to time. Now let this rate of change of current, it is 1 ampere per second. Means di by dt, let it is 1 ampere per second. Okay, then what is the value of L now? L will be minus E or E is equals to minus L and vice versa. So आपल्याला इथं L define करायचं म्हणून मी L is equals to minus E represent केलेलं आहे. That means what is L? L is the opposing EMF. Coefficient of self-induction is a EMF which is opposing. Minus sign आलाय म्हणून opposing EMF. So L is equals to minus E. That means coefficient of self-inductance is a opposing EMF induced in the coil when rate of change of current is unity. Okay, when di by dt is unity means is equals to 1, then only this is the E minus E. That means opposing EMF. Okay, so this is about the self-inductance. Coefficient of self-inductance दोन टाइप मध्ये आपण हे डिफाइन करू शकतो. Now what is the SI unit for the self-inductance coefficient of self-inductance? It is Henry. Okay, by the name of the scientist Henry, the SI unit is given to that is Henry, and it is represented by capital H. Now how we can define 1H or 1 Henry? Okay, L is equals to आपला जो फॉर्म्युला आला होता त्याचाच आपल्याला विचार करायचा आहे. So what is the L? वरची इक्वेशन we just transfer it. E divided by di by dt is equals to L. Okay, so त्याच्यावरून आपण फक्त ही डेफिनेशन मी दाखवली. Just imagine that equation and how to define it. So the 1 Henry is the self inductance of coil in which a change in current of 1 ampere per second produces an opposing EMF produces an opposing EMF of 1 volt. ओके, 1 हेनरी म्हणजे त्यावेळेस सगळ्या इक्वेशन मध्ये इक्वल टू ची सगळ्या व्हॅल्यूज 1 1 असायला पाहिजेत. E डिवाइडेड बाय di बाय dt जे येणार आहे ते पण 1 पाहिजे. सो E ची व्हॅल्यू 1 वोल्ट, di बाय dt इज 1 एम्पियर पर सेकंड. सो 1 1 विल कॅन्सल. दॅट मीन्स L इज इक्वल्स टू 1 आन्सर येणार आहे. सो हियर वी आर गेटिंग दॅट L 1 Henry it is defined as the self inductance in which the change in current of 1 ampere per second produces opposing EMF of 1 volt. Then only it is self-inductance or coefficient of self-inductance of 1 Henry will be there. Okay. So hope you understand this concept of the self-inductance and coefficient of self-inductance. If you have any doubt, then comment here, like our videos and subscribe our channel.